Okay, I'm gonna go ahead and get started just for keeping on time with everything. First of all, thank you all so much for joining us today at this workshop on agent-based models and systemic racism. Also, thank you to MIDAS for putting on this workshop and allowing me to do this mini workshop today. So a little bit of what we expect to go through today. First, we're going to do some introductions. We're going to talk a little bit about this workshop, what we're going to go through, a little bit about me, and then we're going to be using a lot of breakout rooms during this workshop. So I'll put you all into breakout rooms and you guys can get to know who you're going to be working with throughout this workshop. Then we're going to be talking about systemic bias and data science and how that all applies together. And we're going to spend about 45 minutes on that. Then we're going to talk about the agent-based models and how they can be used to examine algorithmic bias. And we'll do about 30 minutes of that. And then we'll do a little wrap up. So after each of these sections, we're going to go into our breakout rooms and discuss a little bit how to apply these concepts on our own field. And the prompts for these breakout rooms are going to get increasingly difficult, more challenging, require you to think a little bit deeper about what we're going through. So I would strongly encourage you to be active in your breakout group and help each other come up with ideas and brainstorm and overall participate in that way. And if you have breakouts or if you have questions in the breakout rooms, you can feel free to ask for help, and it should notify, and Zoom should notify me that I should go to your breakout room. Okay. So before we get started, this main room is going to be recorded, but the breakout rooms are not going to be recorded. The breakout rooms are really just for your benefit and for helping you to solidify these concepts and think through all of these examples. So feel free to dig deeper, explore ideas, make mistakes. Just know it's not being documented in any way. And then along with that, please be active in your breakout rooms. Hopefully you're in a place where you can participate and talk with the other people in there. And if not, just send me a message so that I know to remove you from a breakout room so that the group can fully participate. Okay. So a little bit about me. My name is Holly Hartman. I go with the pronouns she, hers, and hers. I'm a fifth-year PhD student in biostatistics at the University of Michigan. I have my master's degree in biostatistics and my bachelor's in math and molecular cellular biology. And I do a lot of collaborating with the Cancer Center. So that's a little bit about my academic background. In terms of my efforts in diversity, equity, inclusion, I've been pretty involved in the University of Michigan efforts. I'm on multiple committees, our department's committee, the School of Public Health committee. I also completed the Professional Development Diversity, Equity, Inclusion certificate, and I also participated in the Diversity and Inclusive Teaching Seminar. So if you have any questions about this workshop or you want to talk more about some of your ideas, you can feel free to reach out to me. Here's my email address. I also try to be active on Twitter, and here's my Twitter handle. Or if you just want to talk about how awesome this workshop was, feel free to tag me. And then here's my website if you want to know more about me or my research. Okay, so this workshop, we're going to be talking about systemic racism. We're going to be in breakout rooms. Some of this stuff might be somewhat uncomfortable for you. And I want you to know that that's okay. Growth happens when you're stepping outside of your comfort zone. We want you to explore new ideas and feel free to make mistakes because that's when we're really going to learn. However, if you start to feel very, very uncomfortable and you start to withdraw, I would definitely recommend you take a little break, step away, and come back when you're ready and more receptive to learning. There's nothing wrong with taking a moment and taking a little break from all of this. So just know that if you're a little uncomfortable, that's okay. If you're a lot uncomfortable and this isn't going to be productive for you, feel free. You're not bound to be here. So here's some workshops guidelines that I adapted from CRLT. since we are going to be doing a lot of work together, overall, just being a kind and participant, practice kindness and compassion, listen to your breakout room group, encourage everybody to discuss actively. If you're someone who talks a lot, maybe taking a step back. And if you're someone who tends to hold back, trying to be active and make an effort to participate a bit more. So these are all adapted from the Center for Research, Learning, and Teaching here at the University of Michigan. So here's some goals for this workshop. This is what I expect to happen here. First of all, hopefully we will all leave with a better understanding of systemic bias and how those algorithms can continue to promote inequity. Hopefully we'll all leave with some new ideas for research projects. However, these ideas might be pretty rough. They might need some more refinement, or you might just need more time to really sit with this content and further develop your ideas. And then we'll be going over one new tool, agent-based models, for that new research project. Okay, so let's get started with some breakout rooms. So I'm going to work on assigning everyone breakout rooms. So in these breakout rooms, I want you to say your names, your pronouns. So I'm Holly Hartman. My pronouns are she, her, hers. Go through your field, department, or organization, whatever describes where you are currently in your position. So I'm in the PhD program in Biostatistics at University of Michigan. Then your research interests. I'm interested in clinical trial design, health disparities, and oncology research. And then one get to know you question of your choice. So my favorite dish growing up, that was Kraft macaroni and cheese. So you can just pick one of these questions and answer that. So with a little bit more further ado, let me get all these breakout rooms set up nicely. Okay.
The presenter in the seminar, Holly is, and I think she's back just now.
Hello, hello, hello. I am so sorry about that.
Welcome back.
Oh gosh. Okay, I am so sorry about that.
Holly, I'm not sure you're still getting your stuff together, but we had a couple questions while you're away. Did you see that on your iPad?
Okay. Great. Okay, let me look at the questions that there were.
I'm also happy to read them.
Yeah, if you could read them, that would be fantastic.
Yeah. Okay. So Lou asked, and this is, I think, in regards to last slide, where you kind of talked about the different startling statistics about African Americans and Black males. Lou asked, was your data on longer incarceration sentences for Black males broken down by the race of the sentencing judge? And then Aparna was kind of linking another question to Lou's question, asking about if the numbers were controlled for things like income, region, local policy characteristics, etc.
Okay, those are all good questions. And the answer is basically no. So these are looking at overall at the population level, the effects of a person's race on their sentencing. So most of those were about this criminal justice example, I think. And the idea behind me presenting these statistics is more that these differences shouldn't exist even at the population level. Like we shouldn't have to be thinking about adjusting for a person's income when we're looking at racial differences in an ideal world, I mean, because we wouldn't expect the color of a person's skin to actually have any impact on this outcome of being arrested for illicit drugs. So I I did just get these from the sources down here, and I don't believe that they were adjusted for anything along those lines. So short answer is no, these aren't adjusted for anything. The long answer is we shouldn't have to adjust for anything. These are examples of systemic bias, and that's how that shows up. Okay. Okay. All right. So wonderful. Was able to progress the slide. Okay, I'm so sorry. This might go a little bit long since I had everything timed out and that just delayed a lot. Okay. So the next example that I'm going to go through is about school success. And there's a whole field of research on this racial achievement gap. So this form of systemic bias, or this result of systemic bias, is so prevalent that it has its own term. And so one of the effects of that is that on average, Black students score about one, on average, standard deviation less than white students. And that's across different kinds of standardized testing. And so this would be an example of where the outcome is somewhat biased as well. Standardized tests, the questions are designed by people and they are reflective of those people's culture. And those people who are designing the tests might not be reflective of all of the students who are taking them. So there's some bias even within the standardized testing system. So we don't want Black students to be performing worse than their white peers, but we also want to create more fair standardized tests as well. And then over here, I have the high school completion rates as well. So as you can see, Black students and American Indian or Alaskan Native students have some of the lowest high school completion rates, especially compared to Asian or Pacific Islander students and white students as well. So it's about 10%, a 10% difference in high school completion rates between Black students and white students. So this is going to be the final example I go through. So this is in healthcare, which is where I do a lot of my research. So Black women have 3.2 times higher pregnancy-related mortality rates compared to white women. And that is overall across all of the education levels. But one startling component of that is that women who are college graduates have pregnancy-related mortality that's still 1.6 times greater than white women who hadn't finished high school. So we know that education is related to pregnancy-related mortality as well. So we see a trend where women who have less education have higher pregnancy-related mortality rates. And so even college-educated women still have an extremely high pregnancy-related mortality rate. And then in the second bullet point, Black physicians had higher risk of basically tons of diseases, hypertension, cardiovascular, earlier onsets of these diseases, diabetes, compared to white physicians. So by looking at just a physician population, we're looking at a pretty well-educated, high-income group of people. And then we still don't see equal outcomes among this population. And then overall in the US, the life expectancy of people in years. So overall, it's 78.8, and that's primarily driven by non-Hispanic white people who live an expected 78.8 years. And non-Hispanic Black people have the lowest life expectancy. That's almost 3.5. That's 3.5 years less than non-Hispanic white people. And so here, these are outcomes that we do care about, their mortality. It's life and death, literally. And we're seeing these extreme differences in people by their race. So here's a few readings that I think are interesting about the myth of a biological race. So race is a social construct and it has no real actual underlying biology. And so this is a book by Angela Saini. I haven't actually read it yet, but I have it to read. And it's talking about the history of people who have studied race as in the context of biology. And then here's a New York Times opinion piece, How Italians Became White. So our definitions of race have changed over time, and that's just one of the many reasons why we know that these are not biological groups. They are our own social constructs. Okay, here I have a moment for questions. So feel free to put those in the chat or unmute yourself, however you want. Okay, and then, so we're gonna do our breakout rooms again. So we're going to, in our small groups, think about areas in your specific field of research that have this bias, where there are outcomes that differ by some sort of demographic. And so here are some questions to get you started. And this slide is the Room 2 PDF in that folder that Nikki was sending out. So you can think about this in terms of race, but there's also all of these other types of demographics that might be more applicable to your field. Additionally, you might, if you're having trouble thinking about it in context of your actual field, you might think about the institution of academia and who is teaching you these classes and who is represented in your cohort or something along those lines. So I think there's a chat. Oh, that's from Nikki. Okay, so if there are no questions, then I will send you to your breakout rooms.
Do you want to wait maybe like 30 seconds to let people ask any questions?
Yeah. Luckily, it saved the breakout rooms from last time, so hopefully you'll all still be with your same friends. New friends. Okay, I'm going to open the rooms. I'm going to give you guys 5 minutes again. 6 minutes with the 1 minute timer counting down. So I will see you all later. And I believe you can ask for help from me within your breakout room. So feel free to do that if you and your group are having trouble and getting stuck. Oh, unassigned people. Okay, hello again, everyone. Hello. I hope you were able to come up with some good examples for that. So either in the chat or if you want to unmute yourself, I'd love to hear about what you came up with. So some of your examples, if any questions came up or anything that surprised you, or if you had any challenges with that exercise, I'd love to hear more about what you were all doing in your breakout rooms. Oh, I am so sorry. Yes, I will definitely let you know how many minutes you have to discuss, and I'll start broadcasting the messages for how many minutes is left. The next breakout room, I believe you'll have more time as well. So hopefully you can let people who weren't able to speak this time have a chance to speak next time. Someone had to come up with something interesting. So I know that in my research, I do a lot of prostate cancer research. Black men are diagnosed with more severe prostate cancer than white men. And that's partially due to delays in diagnosis, but a lot of different factors. But the fact is that they are typically diagnosed with more severe prostate cancer than white males overall. So that's one example from my arena. And if no one wants to share, then I guess we will go on. Okay.
I'm happy to share an example from my research as well.
Oh, wonderful. Thank you so much. Yes, I'd love to hear it.
So there's been, I think algorithmic bias, and I think you mentioned this earlier, is a big line of research. And just one, I think, specific example is a lot of social media sites use algorithms to determine whether people's posts are toxic or abusive. And they often flag or kind of censor these posts in some way, if they are. And most of the toxicity detection algorithms out there, and actually, honestly, most of the labeled data that's out there for the models to train on are more likely to flag posts that are written in African American English as being toxic. And this actually amplifies existing societal bias, where there's been some research showing that people are more likely to misperceive African American English as being toxic, even just in day-to-day speech.
Mm. That's an excellent example. And yeah, that really comes down to the culture of the people who are designing those algorithms and their not understanding, I guess, of other cultures as well. So thank you so much for sharing. I really appreciate that. And that's such an interesting example as well. So we're actually going to start talking. This is also an excellent segue because we're also going to start talking about how algorithms can contribute to the systemic bias that we see. So a lot of the examples that I have in here are based on this book, Weapons of Math Destruction by Cathy O'Neil. So I'd recommend, if you're interested in this topic, picking that book up. There's also a book that I haven't read, but it's highly recommended. It's called Algorithms of Oppression as well. So those are two resources if you want to dig deeper into these topics. So things to keep in mind to prepare you for our next breakout session as we go through these examples. So how are these decisions made? What data is being used? And how are the resources allocated? So our criminal justice example, we're going to talk about recidivism, which is committing another crime after being previously convicted of a crime. So there's a tool, an algorithm called Compass that's used to predict recidivism in defendants. And this tool was studied and it found that Black defendants were more likely than white defendants to be incorrectly judged at higher risk of recidivism. And then likewise, white defendants were more likely than Black defendants to be incorrectly flagged as low risk. So you can see that in this table here. Of white people who did reoffend, only 23% of them were labeled high risk. And then 44% of African Americans who didn't reoffend were labeled high risk. So these are percents that's incorrectly predicted by this tool. And then down here, of people who did reoffend, of white people who did reoffend, 47.7% were labeled low risk. So it didn't do a good job of predicting if a white person was going to reoffend, is essentially what happened here. So the overall accuracy prediction of this tool is 61%, but that error rate and the types of error varies substantially by race. So in our schooling example, so if we, in this example, there are like several layers of systemic inequalities here. So schools are at least partially funded by income taxes, property taxes, and government grants. And so that means that schools in wealthy areas have more funding and more resources. And then another instance of systemic bias is that white people tend to live in wealthier areas, and that goes back to who was able to get home loans and such. And so the children in these schools with more resources tend to have better outcomes. And then as we were talking about before, those outcomes tend to be test scores or standardized test scores, which also are another instance of systemic bias because they're typically written by and for white Western audiences and aren't fully inclusive. So the end result of this is that white children have better outcomes than Black children. And it's at least partially due to our funding structure of our school, but also how we're measuring success as well. And this was from an NPR article down there. And then this is a healthcare example. So electronic health record data is becoming more and more common used, especially in data science type things like this. It's very up and coming. People love electronic health record data. It's the new big data. Typically, those data come from hospitals that are pretty wealthy. They're able to afford the systems that are part of it. They can be research institutes, and so they tend to be pretty homogenous, and white is the end result of that. And so people are using this data to design algorithms to prioritize patient care. And the end result is that at least one of these algorithms, Black people were given lower priority status compared to white patients who were equally sick. And so they found that this is due to bias in sort of multiple levels of this as well. It comes from the data, it comes from who was creating these algorithms, who was checking these algorithms, and then these algorithms being applied in more diverse populations than what they were trained on. So does anyone have any questions about any of those examples or anything like that? I'll give you a little bit to think about those questions while I introduce our next breakout room. So in the next breakout room, we're going to be trying to think of the policies in our field that allow bias to continue. So I use the term policies because that's pretty common in agent-based models. It's a lot of like economics type research, but this doesn't have to be a policy in the sense that we might think of it. It could be a test, a diagnostic test. What do we do with those results? It could be just a standard operating procedure. It could be an algorithm. We have a lot of data scientists here, so we could call it an algorithm. Anything where you're like, if X happens, then we do Y, and sort of that kind of a policy. And so this will be the room 3 PDF when you go into the breakout rooms. Okay. In regard to the disparity in the prostate cancer diagnosis of Black men they're being diagnosed at later stages, what do you attribute that to? That's a good question. So I think of this as a problem in access to care. There has been some research on this, but not a lot. But this is kind of an idea that I actually have brewing for a research project. I think that Black men have less access to care because, unfortunately, Black men tend to be insured at lower rates. Hospitals tend to be further away from them. They tend to have jobs where they, can't take the time, or they don't have enough of a buffer in their income to take the time to go see a doctor. So I think it's a problem of access to care primarily. And there are lots of reasons as well why Black people tend to go see physicians less than white people. And so I attribute it to that. No problem. Okay, I'm going to go ahead and send you to your breakout rooms. If you have questions, you should be able to flag me. I'm going to give you 8 minutes for this. So I'll warn you when there's, well, I'm going to give you 9 minutes. I'm going to warn you when there's 5 minutes left, and then when there's 1 minute left.
I'll also note there's a timer in the upper right-hand corner of each breakout room as well for people who want to keep track of it.
Oh, thank you, Elizabeth.
No problem.
Okay, and away we go. Hello, welcome back, everyone. Okay, so we're gonna do another debrief after that breakout room. So I'd love to hear some of the examples you came up with, or if you had questions or general feedback. I hope that was enough time for everyone to discuss. Yeah, so my example was kind of what I answered before, was that Black men have less access to healthcare, and so they tend to get diagnosed with prostate cancer later. The algorithm being, or the policy being, access to care, really.
In our breakout room, we talked a little bit about how when you ask for consent for either like a clinical trial or just for researchers at the university hospital to use patient data, often the people who are the most marginalized would be the ones who may not be comfortable with having their data used. So we talked about maybe making it more explicit, like how the data will be used and what the anonymization process is, to make sure that everyone understands what will be done with their data and how it affects them personally, because otherwise we might be skewing towards more educated people, or people who, and those more educated people are likely more white people, and like that kind of builds into us building research models based on a very specific subset of our hospital population, even though we have a more diverse set of patients to draw from.
Yeah, that's an excellent example. And in statistics, we always talk about missing data. So there we would have some people who are missing, not at random, based on their identities. And so that could cause a lot of bias in our estimates for different things as well from the researchers. There's also a lot of mistrust of medical professionals for a variety of reasons among minorities as well. So if they don't fully understand why they need to consent or what their data is going to be used for, it's very reasonable for them to not consent. So that's a great idea of working on how that information is presented to different people. Thank you for sharing that. That's really insightful. Okay. So I'm going to start the next section unless someone jumps in and is like really dying to share, which is totally fine. I know I get excited about this too. Okay, so evaluating algorithms. So this is going to be the part of the talk where we're going to talk about the agent-based models. So agent-based models are a method to describe a phenomenon by creating individual little agents with their own properties and how they act and how they interact with other agents, and then also their world. So each agent-based model has these three main characteristics. So there are agents with characteristics. They have attributes. There's an environment where they exist. And then there are interactions between both other agents and the agents and their environment. So a simple example that's not related to systemic racism is if you want to understand the behavior of a flock of birds. Instead of creating a flock of birds and trying to figure out how it operates and how it behaves, you would create each individual bird as an agent. And you would give that bird a set of rules to follow, how it interacts with other birds and how it interacts with the world. And you would also create the world. So you'd probably have some ponds for the birds to hang out in, some trees, bushes, shelter, and you would set up how those birds interact with their environment as well. And so then you would have many, many bird agents, and you would release them in your world and see how they behave and interact. And through that, you'd be able to see the behavior of the flock overall. So some of the benefits of agent-based models over other types of models, such as differential equations, are that they allow for a lot of heterogeneity. Other models are pretty constrained in just the number of parameters you can put in and the computational requirements, but agent-based models don't have that quite the same. Additionally, you can change policies and allow for experimentation. So if you are doing the flock of birds simulation and you want to know, okay, how do they behave if the birds really hate this one type of tree and they won't go near this type of tree, how does that change their behavior? And along that same line, you can also identify causal relationships. So you can simulate counterfactuals, which would be, okay, let's see how these birds behave when they like this tree and how they behave when they don't like this tree. And you can see the differences in the flock behavior and attribute that to that one small change that you made, allowing you to make causal inference statements about the flock of birds. So how that all connects to agent-based models, or how agent-based models connect to systemic racism, is that agent-based models allow us to answer why there is bias in a certain outcome. They also would allow us to demonstrate the effect of future policies. So I have this figure here from a paper, which was really kind of the inspiration for this workshop, looking at how agent-based models can help us design policy and understand what's going on in our world. So we would create this in this box, our agent-based model. We have social mechanisms, institutional mechanisms, and we have our what they call AI, their algorithm, their policy, whatever that is. And we would simulate this and allow it to run and look at the particular outcome. And then we would do a fairness assessment. We would see, are these outcomes equitable for people of all races, genders, etc., whatever we're interested in. And then as the policymaker, we would make changes to that system until we were able to identify some sort of fair outcome. And then we would be able to potentially recommend this policy or better understand why there is difference in outcomes. So that would be kind of how our agent-based models would relate back to our systemic bias as well. So I'm in biostatistics, so I think about statistics a lot as well. And so how do we measure fairness? In our last little slide, we had this fairness assessment here, but what is fair and how do we quantify that numerically? And this paper that I have cited down here is in criminal justice, but they outline several statistical properties that would result in fairness. So the context here is you have two groups and you have something that predicts outcomes for these two groups. So I think that they were actually looking at sort of that compass type algorithm where they're predicting if someone is going to commit another crime after being convicted. And the two groups were Black defendants and white defendants. So we have overall accuracy equality. So that would be the accuracy of the algorithm is the same for both groups. And then we have statistical variety, where the marginal distributions of the predicted classes are the same for both groups. So the compass algorithm, it spits out a probability of reoffending, and that distribution for white people tends to be pretty uniform. It tends to be pretty skewed. It predicts lower probabilities, whereas for Black defendants, it's pretty equitable or uniform over the range of 0 to 1. So those marginal distributions of what it's predicting are not the same for both groups. And then conditional procedure accuracy, that's when the false negative rate and the false positive rates are the same for both groups. And we saw that that wasn't the case in that table that we looked at earlier, where it was looking at the percentage that were incorrectly classified. And then the conditional use accuracy. So conditional on the prediction of success, the probability of success is equal in both groups. So that would be as if that model predicts that someone is not going to reoffend, then regardless of race, that probability that they actually will reoffend is equal. And then total fairness would be an algorithm that encompasses all of these properties. So here's how agent-based models and why they are useful for examining systemic racism. So They allow us to look at the entire framework of these models in our world. So they allow us to do data generation, processing, decision-making stages, and then all of the consequences all within the same framework. So we don't have to do a multi-step kind of process. We get it all in one smooth application. Like I said earlier, we can make causal statements, so we can look at the causal relationship. And then we can also look at causal mechanisms. So we can say, here's why this was happening, or here's how that ended up the way that it did, because we can actually observe the entire process. And then we can also identify the optimal intervention. So when I was showing you that figure with the loop, we can go through and change our process and change parameters to identify the optimal procedure for how we should proceed. So I'm going to go through an example, but if anyone has any questions right now about those concepts, I'd be happy to take a moment for those questions despite not having a dedicated question slide. So this example that I'm going to go through is based heavily on that paper that I mentioned. It's a scaled down, simplified version of what they explored in this paper. But I tried to maintain some of the concepts that they used in their paper. So this example is about policing. So we are going to start with a world, which is a 50 by 50 grid of cells. And then we have two different kinds of agents. We have group A and group B, and then we have police officers. And so we have different features for all of these groups. So Group A and Group B commit crimes. The police arrest individuals of the groups when they see a crime being committed. So that's when the police officer and a member of each group is in the same cell, and that agent is committing a crime. And so once a police officer arrests someone for committing a crime, that creates a stigma field in the world, where police officers are more likely to return to that same area. And I use the term stigma field because just to match the original paper. So when police officers arrest someone, then they have higher probability of returning to that same area. Other things to note is that Group 1 agents and Group 2 agents are totally separate in this world. They don't interact with each other. There's no overlap in any of that. We also set the crime rates to be equal within each of these groups. And one key part is that police officers start unevenly among the populations. And unfortunately, this is reflective of our actual world, where different neighborhoods and different areas are policed at varying rates. So minority neighborhoods tend to be policed at a higher rate than white neighborhoods, even within the same precinct of police. So those are some of the details. So taking a look at what we have set up all of right now, we have our agents, we have Group A, Group B, and police officers. We have our environment, we have a world of cells, we have boundaries for Group A and Group B, and then we have stigma fields that only apply to police officers. The interactions, we have separate areas for Group A and Group B. Those agents don't really interact with each other. Police can move anywhere in this world, and police arrest members of the groups and create stigma fields. So here is a GIF of what is actually happening. So we have our pink group where they have a high police presence, and we have a yellow group with a low police presence. When the dots are filled in, that agent is committing a crime. We have small green dots, if you can see, or green X's, and those are our police officers. So if we look, I think over here, there will be a stigma field that appears when a police officer is in the same area as an agent committing a crime, and that area lights up, and that's our stigma field. So the police officer has a higher probability of returning to that area. Okay, so that's our setup. Here's a little demonstration of what's going on. So let's look at the number of arrests made in each group in this scenario. So we can see here that the group with the higher police presence is being arrested at a much higher rate than those with the lower police presence. And that difference, it continues to grow between the two groups. So now what would happen if we removed those stigma fields? So police still start unevenly distributed, but they have equal probability of moving anywhere in the world. They don't care about if a previous crime was committed in that area. So we see that there is still a difference between these two groups, likely just due to the starting position of the police officers. But the slopes of the lines are kind of similar. They get arrested kind of at the same rate after a while, where the police have intermixed between the populations evenly. So here's a side-by-side comparison of what is happening in those two scenarios. So when we have the stigma field where the police are more likely to return to those same areas, we have this huge difference. And then when we have no stigma field, there's less of a difference. And one thing that's interesting to note is that the yellow group, group 2, gets arrested at a higher rate when there is no stigma field. So in this ideal world where they commit crimes at similar rates, you would like to have them, you would like to have the same amount of people arrested both from group 1 and group 2. And so here you're actually missing a lot of crimes from that group 2 because they are focusing all of their energy on group 1 with the higher policing rate. So here's another way to look at that data. This is the proportion of arrests that happened in group 1, in that pink group, and in our two scenarios. So this is the scenario where there are stigma fields, and this is the scenario where there's no stigma fields. And this axis is the proportion of arrests from group 1. And it goes from 0.5 to 1. This isn't 0. So ideally what we'd like is for a line to be straight across at 0.5. We'd like half of the arrests to be from each group because they commit crimes at the same rate. And you can see that with the stigma field, that difference is actually increasing as time goes on. And with the no stigma field, it's sort of approaching 0.5. So one thing that to highlight is that this is just one simulated run of this example. So all of these little fluctuations, like why does it go up like that, is probably just due to randomness in that one scenario that I set up. So to correct for that, I ran these a bunch of times and I looked at the median proportion of arrests over time. So here we have our well, these are labeled incorrectly. Here we have our example where there's no stigma field, and here's where we have a stigma field. And you can see that on average it decreases and starts to approach that 0.5 that we hope it would approach in the end. And this we see that it's like slowly increasing over time. So these stigma fields, although that policy might make sense in conception, you know, if a crime was committed in an area, you'd like to police that area more because maybe another crime is going to happen there. This is where we get the idea of bad neighborhoods. So in practice, and like if someone just presented you that idea, you might be like, oh yeah, that makes sense. But in practice, it actually results in uneven policing and this bias here because we set up these parameters. We know these two groups commit crimes at the same rate. So another thing to note is that this example is really, really, really simple. I did this primarily for just demonstrating agent-based modeling in the context of systemic racism. So I never removed any agents after they were arrested. They still were all around. Arrests happened with probability of 1, which is not true. We also didn't go through any of the sentencing processes or anything like that. I didn't change their probability of committing a crime after they were arrested, so I just like made it very simple. Group agents don't respond to each other, they don't respond to police officers, and they don't respond to stigma fields either. And so lastly, the real world is not clustered neatly like that. We do have some clustering, but it's not like totally divided like that. There's also more than like a 50 by 50 grid of cells that you can move about in the world. So if I were to want to explore this further, I would add more complexity to this. I would add more rules about how the agents interact, and that could change my results. But overall, you can sort of see the idea of this stigma field creating more bias in the outcomes, which is how many people are arrested from each group. So there's a lot of tools for implementing agent-based models. There's Repast, there's NetLogo, and Mason. And the most common is NetLogo. This is a program that was actually originally designed for children, so it has some interesting terminology in it. I think that turtles are a common or an agent in there. And NetLogo also interacts with R through RNet logo, not Lego, and Python through PyNetLogo. And here are some resources that can help you potentially learn more about how to implement agent-based models. So NetLogo has some very thorough tutorials that have been documented. So you can work your way through the tutorials. There's also this R bloggers post about our NetLogo. There's PyNetLogo documentation. This article is a sort of walkthrough on how you might design an agent-based model and things to think about as you go through. And then here's the, down here is the paper that this simulation was based on, along with the GitHub repro. So I'll let you guys ask questions while I introduce our final breakout room. So this final one is the most challenging, and it's thinking about how you will apply agent-based models in your field. So thinking about those examples that you worked up for systemic bias and the algorithms that promote bias. So think about what are the agents in that setting, what is the environment, and how do they all interact with each other. So so we're just about, we're at 4:10. So I originally had this get planned for 10 minutes, and I think I'm going to keep with that. Okay, Catherine Griffith asked a question. How new or innovative is the use of agent-based models to study social issues? So it's fairly common in economics and like how shoppers will move about stores and how they interact. It's a lot more common in that field. I have seen pretty few articles about agent-based models in social issues. That's why I cited that Cortez and Ghosh paper quite a bit, because that's one of the first places that I had really seen it come up. I haven't seen it in healthcare really. I haven't yet. I hope to. It's all more of a work in progress. Oh, the question was, are you publishing anything on this work? I plan to. I haven't yet. But yeah, so this is kind of why, or how I designed this workshop, was to help bring agent-based models to the social issue arena and try to help all of us come up with those ideas for potential research projects. So any ideas you come up with here, you can go out and look up if they are, if somebody's already done it, but I'm not I would be surprised. Are there downsides to agent-based models present in that aren't present in usual models for social issues? So one thing is that you have to decide how things act. You have to come up with some assumptions, basically, about how the world works, how people interact. So you have, while you have a lot of flexibility, that flexibility comes with also a lot of things you have to decide on. But one nice thing about these models is that, oh, there you go. Thank you, Lou. He said that the use of ABMs in social science goes as far back as 1971 with Schelling's model of segregation. Thank you. So back to downsides, you have a lot of control, and with that comes a lot of assumptions you have to make is basically one of the downsides. Additionally, it takes a while to run simulations, especially complicated ones. So it would be beneficial to have access to high computing power, and not everyone has that. Okay, so I'm going to send you all to your last breakout rooms. If you have to leave at 4:15, feel free to, but otherwise I'm going to just continue on. I think I'll let you be in your breakout rooms for about 10 minutes, and then I will wrap up, which should be only 15 minutes. So we'll be done by 4:30. Okay. I will see you all later. Welcome back. Not everyone is back yet, though. But they'll be back in 8 seconds. Okay, hello, everyone. Welcome back. I hope that you had interesting conversations. This was an especially challenging one. So if you didn't come up with something, that's totally okay. Like, this is some new concepts, some new ideas. This whole workshop is really meant to be more idea generating than like a product generating. So if you need to sit with that content a little bit more, that's totally fine. You can also reach out to me if you'd like a little extra assistance, like if you think you're getting there and you just need a little bit extra feedback. I'm more than happy to talk with you about your ideas. So on that note, I'd love to hear about what you guys talked about in that final breakout room. What ideas came out of this? If there's anything that you need to learn or explore a little bit more to further pursue this. Yeah. So my idea with the prostate cancer and access to care, I think I would like to set up, here's my paper idea or project idea. I'd love to create an agent-based model where we have hospitals and people and agents of different races, and seeing the effect of potentially diagnosing Black people sooner with prostate cancer, and see how we can potentially do that, maybe by providing more testing in different clinics, maybe by more routine screening in that population, and trying to explore that as a concept. So.
Holly, I have a question.
Yeah.
When you have a trait that has both effects coming from systemic racism and genetics, is there a way to adjust for the genetic component that might lead to part of the disparities?
Yeah, so one thing that you could potentially do in your agent-based model is, thinking about our crime example, we could set the groups to have ever so slightly different rates of committing crime. However, we would still think that with the increased policing and the increased stigma fields, that one group would still be over-policed and end up being a larger chunk than we would expect to be, even given a small difference like that. So that would be a way to incorporate it into these agent-based models, I would think. However, there's a lot of traits that aren't actually associated with genetics that are racially different. So that book that I recommended, Superior, talks about how race has been studied, and sort of talks about why the biology of different races isn't really a thing. I hope that helps.
Yeah, I think for me the struggle with that is the gene I look at, the variant is only found in people of African ancestry, and I know that ancestry and race are not the same. But when thinking about systemic racism, you get to doubling or the overlap of the effects of both, and it's hard to
Yeah.
disentangle that. And I didn't know if these models would be able to do that by accounting for the ancestral differences.
Yeah, you could also, one interesting idea would be to create an agent-based model where you have like the different underlying properties being different of the two groups, and that would be sort of the genetics. And then you have the societal aspect of it as well. And then you could potentially also alter those. You could say what happens with no societal impact, or you could say, what if this genetic, or what if like we mix all together and become sort of a homogenous population, and what would that look like? And you could also probably tweak your settings until it reflects what is actually seen in your data to try to say how much of this is related to the ancestry and how much is just related to societal impacts as well.
Thank you.
Yeah.
I think along those lines, one of the things I was wondering about is I think there are many different things that people attribute to kind of in your case, you know, the differential policing and the differential rates of incarceration. And I think the question of like, you know, where do people patrol is one of them. And there are obviously many others, including like just, you know, what the person looks like, kind of the police officer's own innate biases. And I think just maybe potentially adding like more of these layers into the model would allow you to understand, number one, to what extent do these different factors actually contribute to bias, but two, to understand that if you really put a lot of real data into the model, to understand to what extent do all of these different factors that we're attributing explain the kind of the differences in outcomes to the extent that we're seeing in the real world. I don't know if that made sense.
Yeah, no, I think those are good points. I think especially what you were talking about in the example with the policing, I didn't add any sort of actual bias to the police officers, whereas we know that everybody has a little bit of unconscious bias in them. And so while the actual police officers themselves, their actions were totally unbiased based on, like, it didn't matter if the agent was in the pink group or the yellow group. In practice, that may be an unfortunate truth that we would have to put into the model. So I think that's a good point. Okay, just for the sake of time, I'm going to wrap up, but if you want to stay and talk more, you have more ideas, I'm happy to stick around for that. So I just want to go over everything that we talked about today. So we went through examples of systemic bias, and we explored some of the algorithms that that contribute to these inequitable outcomes. We had an introduction to agent-based methods. We saw an example of how agent-based models can reveal bias. And we discussed systemic bias in our own fields and how ABMs could potentially be applied there. So thank you all so much for coming to this workshop, and thank you everyone for staying a little bit later. I apologize for the technical difficulties. Here's my email if you want to reach out, my Twitter if you want to connect that way, and also my website if you're like, who was this person that was talking for an hour and a half? And with that, I will stick around. We can continue to discuss this. I'll also probably join potentially the networking session that's happening next at MIDAS. So thank you all so much for coming and staying. Really appreciate it.
Hi, Holly. I had something I wanted to ask you about.
Yeah.
So in our group, I teach in the architecture school in sort of computational design context, and so when you thinking about agent-based modeling, you know, there's been a lot in my area. There's been a lot of sort of modeling of these what I would call somewhat neutral systems, like the flocks of birds and slime molds and these different kinds of complex systems. But what doesn't tend to happen is that people choose to model more, let's say, contentious systems, like say how a race-based system or some kind of racist model, and so I was wondering, I'm interested in, say, like computational literacy. So how we teach these skills, right? How we teach about computational thinking and different kind of programming systems, and yeah, just what your take is on, for instance, whether you would ever consider teaching, when thinking about agent-based modeling and complexity, whether you would ever think about teaching it from a perspective in which the context is somewhat socially contentious, as opposed to, say, teaching these kind of more foundational skills from a supposedly more neutral ground, like a flock of birds.
Yeah.
I just wonder if that ever comes up, because I think about this a lot in terms of teaching programming literacy.
Yeah, no, that's all super, super, super cool. I definitely think that presenting this concept in a context with some societal aspects like systemic racism I think it is a good thing. I'm on the Biostatistics DEI committee, a student committee, and we are currently trying to get our professors to incorporate more examples with societal implications. So as a student, I know that my classmates and I are all very interested in this, and it helps especially like apply these concepts, because we don't interact in a world where everything is neutral like that. And so thinking about these concepts in a different manner is sometimes useful. I wouldn't say like all examples should necessarily be like this, because that can be just kind of taxing when you're constantly thinking about these difficult, complex issues. But presenting things at least once with a social justice kind of theme is definitely useful. And I think it helps make fields more inclusive as well. I know that CRLT also has I think they have either workshops or consultations on how to incorporate DEI topics into different courses. So I'll find that page, and I'll send it to you. Did you register for this workshop?
Yeah.
Okay, great. So I have your email address then, so I'll send it to you.
Okay, that's cool. Thank you.
Yeah, no problem.
Yeah, thank you so much for the workshop. It was great.
Oh, I'm so glad. I'm glad to hear that. I was nervous.
Oh yeah, no, I personally, I find it a really important thing, like taking agent-based modeling and a different system like systemic racism and trying to sort of force those together for a moment. Like a really kind of provocative, powerful move. So
yeah.
Thank you.
Well, thank you. And I will send you that link as well.
Okay, great. Thanks. Bye.
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 Okay, I'm so sorry. But I needed. You need to go potty? Yes. You both do need more food. Okay.